It's Mr. Rops here, and I got my super helper with me as well. Here's Riley.
Okay.
So we've been doing this thing called factoring, but my big question is, what in the world is factoring in the first place? What does this factoring mean? Well, in order to do it, let's consider this. I'm going to expand this out. I'm going to multiply x times x, so x squared. I'm going to multiply x times 5, which is 5x. Negative 4 times x, which is negative 4x. And then negative 4 times...
20.
Oh, thanks. Collecting like terms, what do you get? X squared.
Are you asking me?
Yeah.
For like all of them or
Right, what's the... If I go 5x minus 4x, I get...
X?
Right, plus 1x, or just x,
Yeah.
minus
20.
20. And so this operation here, the way when it's in factored form, this here is factored. This is the product. And so when I go one direction, when I go
Right, you just using
this
FOIL on that?
direction, yep, it's FOIL. This is multiplying. Okay? When I go in that direction, it's multiplying. When I go in the other direction, though, when I go in this direction here, oh, ignore that. When I go in this direction here, that is factoring. Okay, factoring. So factoring is undoing multiplying. It's looking to go backwards. So the same thing if I look at 36. What are two factors of 36? Well, 4 times 9. That's kind of undoing multiplying. I'm looking for the things that multiply to get 36. That's just one possibility. So factoring is kind of undoing multiplying. So in doing this, now I'm going to consider this scenario here. And when I have this kind of technique, I have to recognize that this is called a quadratic because it's x squared. And in this case, the number in front of the x squared, this coefficient is 1. And that's key because we're only going to look at when a equals 1 for today. And so whenever we have this scenario, we have to ask ourselves what I call the magic question. The magic question. And what the magic question is, it asks me what two numbers multiply to get 50, a positive 50, and at the same time add to get negative 15, this middle number here. Okay, and so when we look at quadratics, I always consider ax squared plus bx plus c. This is the case where a is equal to 1. So this is 1 here. This 50 is c. And this 15 is negative 15 is b. Okay, so what two numbers multiply to get c and add to get b?
5 and 10.
Right, exactly. Riley's already done that. You have to do a bunch of mental math to do it. We know it is 5 and 10. We know its x is 5 and 10. Now we've got to be careful here because they have to add to get a negative 15 and multiply to get a positive. So if I multiply and get positive, what do we know about both these numbers? They can either both be positive or both be negative.
So they both have to be negative.
Exactly, to get negative 15. So negative and negative. And so when we answer this magic question, we get our factors. Let's try another one. Okay, so I want to factor it and ask the magic question, what two numbers multiply to get negative 30 and add or combine to get a negative 7? Well, what numbers multiply to get negative 30? Let's think about that. Let's ignore the negative for a moment. So factors of 30, I could get
3, 10.
3 and 10. I can get
9, 30.
5 and 6, 1 and 30. Are any of these 2 and 15. Any of these combinations of pairs, could you combine them somehow to get a negative 7?
You could do 3 and 10, but one would have to be
Right. Which one's got to be negative?
10. Could
Right.
be negative, and the other could be
Right. If I have this combination, I get negative 7. And so it ends up being x minus 10 and x plus 3. Double check. They multiply to get negative 30, combine to get negative 7.
Is there always a magic number?
That's a good question. For the ones that I give you for now, there's always going to be one. But in the world, there's lots that do not have these magic numbers that work out nicely. Okay, so now this one's a little bit tricky. Okay, we're going to ask ourselves what two numbers multiply to get a negative 81, and they add, well, there's no x term. It's like x squared plus 0x minus 81. It adds to get 0. So what numbers do you know multiply to get 81?
Oh, like 81.
On 1, yep.
1.
And,
9.
9. Right, 9 times 9 gives me 81, right?
Yeah.
Could I add them somehow, positive negatives to get 0?
9, like positive 9 minus negative 9.
Exactly, so it's
Minus
x
9.
minus 9 and x plus 9. And this is a common pattern. Whenever you have a scenario where there's no middle x term, it's often going to be the two numbers are the same, and this is called a difference of squares. But I still use this method, thinking of the magic question, to do the factoring. All right, so this one here, this one's a bit trickier because look what we have in front there. It's not 1. So all our methods that we've done so far don't work. But what do you know about 2, 14, and 36?
They're all even.
Exactly. So the first thing I'm going to do is I'm going to pull out a common factor. Because they're all even, I can pull out a common factor of 2. If I pull out the 2, I get x squared plus 7x minus, take 2 out of 36, and I get 18. Well, now this inside part, I can ask myself the magic question. Do you remember the magic question, Riley? What two numbers multiply to get
18.
positive or negative 18?
Negative 18. And add to get positive
7. All right, what numbers multiply to get 18?
Oh, 2 and 6.
9.
9.
Or 3 and 6?
Yeah, 3 and 6. 1 and 18.
Right. I want to somehow get a positive 7. Can I combine 2 and 9 somehow to get a
Yeah.
positive 7? How do I do that?
9 minus 2.
9 minus 2. So the negative 2, positive 9. So it's x minus 2, x plus 9. Double checking that. Negative 2 times positive 9 is negative 18. And negative 2 plus 9 is 7. And so this is the full factorization of this. And so look for a common factor. That's a key step. And that is all we have for today.